Hey everybody, today I'm going to talk about lipids, which correspond to information that's in chapter 6 of your textbook. So lipids, a lot of times in nutrition, we call lipids fat. So I'll tend to use those terms interchangeably, fat, lipid, they mean the same thing. And these are molecules that get grouped together because they don't mix with water. So because they don't mix with water, we call them hydrophobic. So hydro means water, phobic means afraid of. Lipids don't mix with water. And there's no recommended daily allowance for lipids. There is macronutrient distribution range recommendation though, and that means what percent of your calories should be coming from different macronutrients. In the case of lipids, it's about 20 to 35%. And there's some types of fats that we know are hard on our body. Those are going to be saturated fats and trans fats. So we recommend that people limit their saturated fat intake because it's linked to heart disease. So the American Heart Association is going to recommend not taking in very much saturated fat and not taking in a lot of cholesterol, which is another type of lipid. And both of these are found in high amounts in animal foods. So we need lipids in our body, or we need fat in our body for a variety of reasons. One of the big ones is it's how our body's going to store excess energy. So when you take in more calories than your body's going to need, it's going to store those excess calories as fat. And it's a specific type of fat that we call triglyceride. And those get stored in our fat tissue. And the term adipose is kind of a fancy way to say fat. They give our body shape. Fat insulates us, so we all have a layer of subcutaneous fat. As I said, it's how we store energy. It protects us, so our vital organs are surrounded by a thin layer of fat, and that helps protect them. Oils can be protective and act as lubricants, so like secretions that you produce have lubricating abilities. That's because of fats in them. And then we need some types of fat. One of them that we need is cholesterol, and this is because it'll get in our membranes of our cells and help them stay fluid. And it's also a precursor for making lots of hormones like testosterone and estradiol. So when we talk about lipids, what we're going to do is divide them into 3 groups. Those 3 groups are listed here. The big one is the triglycerides. And when we say fat in nutrition, usually we're talking about triglycerides. So we'll go through what these are made out of in a slide or two, but I have it written out here. They're made out of 3 fatty acids and something called a glycerol. We're also going to talk about another type of lipid called phospholipids. And the main thing I want you to know about phospholipids is this is what makes the membrane of all our cells. And then the third type of lipid we're going to talk about are sterols or steroids. And this is what cholesterol is going to be. So we'll start with triglycerides, which again, we just commonly call fat in nutrition. These are made out of 3 fatty acids and a glycerol. So this glycerol molecule shown in blue, and all it is a 3-carbon molecule. And when a condensation reaction would occur between a glycerol molecule and 3 fatty acids, so these fatty acids are these long hydrocarbons, you'd get what's called a triglyceride. So here's the glycerol molecule, and it has these long hydrocarbons coming off of it that are called fatty acids. So this is the basic structure of a triglyceride. I want you to know it's made out of a glycerol and 3 fatty acids. These fatty acids now can be different shapes and have different lengths. So when we draw these squiggly lines, each point represents a carbon atom, and they can be different numbers of carbon atoms in length. And that's what we mean when we say short chain, fatty acids, medium chain, or long chain. And you don't need to know the specific, like what a short chain is versus a long chain, but it just refers to how many carbon atoms are going to be in those fatty acids. Now, the big thing I want you to remember about triglycerides and the fatty acids on them is their saturation can differ. So you probably heard people talk about saturated versus unsaturated fats, and I want you to actually know what that means. The saturated fats mean the fatty acids are saturated, where they have as many hydrogen atoms as possible on the carbon atoms. So typically that means the carbons in the chain have 2 hydrogen atoms, and the one on the end has 3. So I'll show you what that looks like in a minute. Here, I can show it now, I guess. So here's a fatty acid. If all of these carbon atoms have 2 hydrogens associated with them, and then the one on the end has 3, we say that it's saturated. So what that means is it's saturated, the carbon atoms are saturated with hydrogen. Now, if a molecule or fatty acid is unsaturated, that just means those carbons aren't saturated with hydrogen. So here would be an example of an unsaturated fatty acid. You can see these 2 carbons are only bound to 1 hydrogen. So the really, really easy way to distinguish between a saturated and an unsaturated fat is just look for a double bond between carbon atoms. And if you see a double bond, that means it's unsaturated. So there could be 1 double bond. We call those mono unsaturated fatty acids. Mono means 1, or there could be multiple. And typically, those are called polyunsaturated fatty acids. So generally speaking, saturated fats aren't as good for you, and they come from animals. And unsaturated fats typically come from plant sources and are a better health choice. There are a couple of unsaturated fats that are essential. That means our body needs them, but our body can't make them, so we have to take them in through our diet. So these essential fatty acids are called omega-3 and omega-6. So I want you to know there are some essential fats. They're unsaturated fatty acids called omega-3 and omega-6, and that 3 and 6 just refer to where the double bond is. So we need these 2 fatty acids, omega-3 and omega-6, because what they are precursors to molecules called eicosanoids. And what eicosanoids do is they help our vessels contract and expand. And if we don't have enough omega-3 and omega-6, we can't make enough eicosanoids, and we can't vasoconstrict or vasodilate very well. And that's going to cause all kinds of problems, like you're not going to be able to clot, you're not going to be able to control your blood pressure. Early symptoms of that would be shown here, but ultimately, if you don't take these in, you will die, right? So there's lots of different sources to get omega-3 and omega-6. Basically, if you eat real food, like plants, you'll get plenty. The fish industry has kind of hijacked the omega-3 and omega-6, and a lot of people think you need to eat fish or seafood to get these, and you don't. It has omega-3 and omega-6, but lots of things do, right? So like canola oil has it, flax seeds have it, lots of nuts have it, and lots of greens have them as well. So you can get it from a variety of sources. And when we're talking about saturated fats and unsaturated fats, sometimes people have this notion that a type of food is all or none, and that's not true. Generally speaking, fats from animals are going to have more saturated fat. So if we look at like these dairy products, they're primarily going to be saturated. And if we look at these plant products, they're primarily going to be unsaturated. Rarely is something all or one or the other. Usually they're a mix. And usually what you find are fats that are primarily saturated are solid at room temperature. So if you look here, like butter is primarily a saturated fat and it's solid at room temperature. And that's because those fatty acids, when they're saturated with hydrogen, form straight lines and the molecules can stack on top of one another and they'll form solids at room temperature. Versus unsaturated fats, when you have a double bond in the molecule, they bend. And when they're bent, they can't stack up on one another. So most unsaturated fats are going to be liquid at room temperature. So like your, things like olive oil is liquid, right? And that's because it's primarily unsaturated fats. All right, so the functions of triglycerides in our body are, again, if we eat them, they have calories, right? They have 9 calories per gram, so they can provide energy to us. They're also how we store energy. As I mentioned before, when we take in more calories than our body needs, we'll store that away as triglycerides in adipose tissue. They're going to insulate and protect us. So they insulate our vital organs and help cushion them. And then there's some vitamins and that are fat soluble. So that means they dissolve in fat, and we need to take in fat to actually absorb those. And then finally, the 2 essential fatty acids are omega-3 and omega-6, and they're precursors to these molecules called euglycanoids that help us vasoconstrict and vasodilate. So again, I want you to be able to look at a fatty acid and tell me whether it's saturated or unsaturated. And the easy way to do this is just look at the carbon atoms. And if there are no double bonds between carbon atoms, it's going to be saturated. And typically, saturated fats are in high abundance in animal products, and they form straight lines, so they form solids at room temperature. Unsaturated fats will have a double bond somewhere in between the carbon atoms, and this constrains the molecule into a bench form. These are common in plant fats, so they're going to typically be liquids at room temperature. Hold on one second. Please excuse me. Cash.
I hate my life.
Thank you.
No.
Now the third type of fat that becomes important in the nutrition world are trans fats. And these are usually generated artificially through a process called hydrogenation. And what happens here is a unsaturated fat has the hydrogen atoms rearranged, and that gives the molecule properties of a saturated fat. So basically it kind of locks it in the straight line conformation. And this is again typically not found naturally in our natural world. It's made in most products through a process called hydrogenation, and it's really, really, really bad for you to eat a lot of trans fat. And that's because it's intimately linked to heart disease. So again, this happens through a process called hydrogenation. Food companies love to do this because it would extend the shelf life of their products. And the longer they can keep something on the shelf, the more profit they can make. Now, historically, you'd find trans fats in things like vegetable shortenings or margarine or a lot of frozen foods like frozen pizzas and frozen desserts would have them. But this is so bad for you that in America, trans fats are being banned. So you're not even gonna have the option to take in a lot of trans fat. Right now, food companies can still have trans fat though in their food if it's below a certain percentage. They rarely call them trans fats, though. What they call them are partially hydrogenated oils. And that means the same thing as trans fat. So usually what you need to do on the food label is look for the term partially hydrogenated oil, because food companies don't usually call them trans fats because they know the general population knows trans fats are bad. So I have a little video that I wanted to show you that just overviews some of what I just talked about.
Olive oil is 100% fat. There's nothing else in it. Pancake mix, on the other hand, is only about 11% fat. And yet, olive oil is good for you, and pancake mix is not. Why is that? As it turns out, the amount of fat we eat doesn't impact our weight or our cholesterol or our risk of heart disease nearly as much as what kind of fat we eat. But let's back up. What is fat? If we were to zoom in on a salmon, which is a fatty fish, past the organs, past the tissues, into the cells, we would see that the stuff we call fat is actually made up of molecules called triglycerides, and they are not all alike. Here's one example. Those 3 carbons on the left, that's glycerol. Now you can think of that as the backbone that holds the rest of the molecule together. The 3 long chains on the right are called fatty acids, and it's subtle differences in the structures of these chains that determine whether a fat is, let's say, solid or liquid, whether or not it goes rancid quickly, and, most importantly, how good or how bad it is for you. Let's take a look at some of these differences. One is length. Fatty acids can be short or long. Another, more important difference is the type of bond between the carbon atoms. Some fatty acids have only single bonds. Others have both single and double bonds. Fatty acids with only single bonds are called saturated, and those with one or more double bonds are called unsaturated. Now, most unsaturated fats are good for you, while saturated fats are bad for you in excess. For saturated fats, the story pretty much ends there, but not for unsaturated fats. The double bonds in these molecules have kind of a weird property. They're rigid. So that means that there are 2 ways to arrange every double bond. The first is like this, where both hydrogens are on the same side and both carbons are on the same side. The second way is like this. Now the hydrogens and carbons are on opposite sides of the double bond. Now, even though both of these molecules are made up of exactly the same building blocks, they are 2 completely different substances, and they behave completely differently inside of us. The configuration on the left is called cis, which you've probably never heard of. The one on the right is called trans, and you probably have heard of trans fats before. They don't go rancid, they're more stable during deep frying, and they can change the texture of foods in ways that other fats just can't. They're also terrible for your health, by far worse than saturated fat, even though technically they're a type of unsaturated fat. Now, I know that seems crazy, but your body doesn't care what a molecule looks like on paper. All that matters is the 3D shape, where the molecule fits, where it doesn't, and what pathways it interferes with. So how do you know if a food has trans fat in it? Well, the only sure way to know is if you see the words partially hydrogenated in the ingredients list. Don't let nutrition labels or advertising fool you. The FDA allows manufacturers to claim that their products contain, quote, 0 grams of trans fat, even if they actually have up to half a gram per serving. But there are no hard and fast rules about how small a serving can be, and that means you'll have to rely on seeing those key words, partially hydrogenated, because that's how trans fats are made, by partially hydrogenating unsaturated fats. So let's go back to our olive oil and pancake mix from before. Olive oil is 100% fat. Pancake mix is only 11% fat. But olive oil is mostly unsaturated fat, and it has no trans fat at all. On the other hand, more than half the fat in pancake mix is either saturated or trans fat. And so even though olive oil has 10 times as much fat as pancake mix, it's healthy for you, whereas pancake mix is not. Now, I'm not trying to pick on pancake mix. There are lots of foods with this type of fat profile. The point is this. It's not how much fat you eat, it's what kind of fat. And what makes a particular fat healthy or unhealthy is its shape.
All right, so That just highlighted some of what I tried to go over. And the big thing there is you want to know what a triglyceride is, what it's made out of, so glycerol, fatty acids, and then be able to tell me the difference between unsaturated, saturated, and trans fats. So the next type of lipid we're going to talk about are phospholipids. So phospholipids have a head group that's shown as this ball that likes water, and then they have these fatty acid tails that are hydrophobic, or they don't like water. So when you get a bunch of these fatty acids together, they tend to form what's called a lipid bilayer, where the head groups will be next to water and the fatty acid tails would exclude water. And because of this property, they tend to form, again, what's called lipid bilayers. And these are what primarily make up cell membranes. Okay, so cell membranes are primarily made out of phospholipids. They can also act as emulsifiers. So a lot of times, like detergents are going to be made out of phospholipids, and they can do things like surround oily substances and emulsify them and help you clean them up. So that's all I want to say about phospholipids. The third type of fat, or the third type of lipid we're going to go over are sterols. Sometimes these are just called steroids. And a sterol is any molecule that has this 4-member diffused ring. So the chemistry coming off of that ring can be different. Here you're looking at what cholesterol looks like. So cholesterol is a type of sterol. And there's lots of functions for cholesterol. It's a precursor to making sex hormones. It's a precursor to making bile, which helps us absorb fat. It's found in our cell membranes, and it's found in these things called lipoproteins, which I'll tell you about in a minute. So we don't need to eat cholesterol. It's not essential for us to eat because our body makes it. So your liver will make all the cholesterol that you need, and only animals make cholesterol. So you're an animal, you make cholesterol, and when you eat animals, you're getting cholesterol from them. So plants don't have cholesterol. So a lot of people have issues with having high cholesterol levels. You probably know people that have high cholesterol, and we care about that because it's intimately associated with developing cardiovascular disease. So the easiest way to lower your cholesterol level is not to eat it. And the way not to eat cholesterol is not to eat animals or animal products. So again, these are the 3 types of fats, or 3 types of lipids: triglycerides, phospholipids, and sterols. And I have another short video that tries to drive home some of these main points that I've just been talking about.
Be healthy. The problem with that is that it's complicated. It's too complicated to fit into a headline. Eating lots of fat will make you unhealthy, but so will eating lots of anything. Studies show that cutting fat intake is useless when attempting to help people lose weight if those calories are replaced by something else, which they tend to be. Now, fat is relatively straightforward chemically, but it's boggled dietary scientists and especially journalists writing about it for decades. But the basics of what we understand aren't that complicated. So let's get to the heart of fat. Fats are molecules that organisms use to store energy. They are very good at that, and so they can be converted into lots and lots of energy for running an organism, whether it's a seed growing into a plant or a neuron firing in your brain. But basically, the first thing to know about fat is that it is energy dense. So per gram, fat has more than twice the energy of protein or carbohydrates. Fats, like everything we eat, are made of chemicals, and those chemicals are primarily composed of long chains of carbon atoms. Each of those carbon-carbon bonds can be broken by your body and converted into usable energy. healthy. The energy density of fat, combined with the fact that people who ate high-fat diets tended to be less healthy, was the original cause of the anti-fat craze that started in the 60s and continues, at least to some extent, today. But it turns out that fats are not inherently bad for you. Indeed, they are an absolutely necessary part of the diet. But there are definitely some fats that promote health more than others, and some that are downright dangerous. You've heard of the main categories. You got your trans, saturated, unsaturated, hydrogenated, polyunsaturated, omega-3. All of these words are chemistry terms that get talked about a lot without discussing what they mean, like, at all. But this is SciShow, so let's go there. Carbon has 4 unpaired electrons, so each carbon likes to bond to 4 other things. This is methane, carbon bonded to 4 hydrogens. And yes, I'm using Snatum's Veritasium's molecular modeling kit, which I'm really excited about. If the carbon is in a saturated carbon chain, 2 of those things will be other carbons, unless it's the end of the chain, and 2 of those things are going to be hydrogen. If this is what the carbon chain looks like, with a bunch of carbon atoms each bonded to 2 carbons and to 2 hydrogens, that is a saturated fat, which tend to be solid and are mostly made by animals, though also coconuts. The thing that saturated fats are saturated with is hydrogen. Every carbon is bonded to 2 of them, except for the last, which is bonded to 3. And unsaturated fats are not saturated. They have fewer hydrogens. How? Well, they've got at least 1 double bond between 2 carbons in the chain. Each double bond means 2 fewer hydrogens. So unsaturated fats don't have as many hydrogens as they could have per carbon atom. And this is not as minor a change as it might sound. Single bonds can rotate around their axis no problem, but double bonds lock a structure into place. And that double bond can either lock the chain into a kink or lock it straight. In nature, a double bond in a fat chain almost always locks it into a kink. This prevents the fat molecules from stacking into lattices, making them more likely to be liquid at room temperature. So unsaturated fats tend to be liquid, making them oils, and come mostly from plants and fish. The kinked configuration is called the cis isomer, and the straight one is the trans isomer. The word isomer just means that the molecules have the same chemical formula, but are different shapes. And the different shapes matter a lot. Saturated fats are less healthy than unsaturated fats because they pack together easily and can form plaques in your arteries, and can also interact with cholesterol, making it build up in your bloodstream. Cis unsaturated fats, which the rest of the world just calls unsaturated fats, don't stack well and so don't form plaques. So that difference exists, but it isn't as big as we used to think it was. It turns out that our bodies are pretty good at dealing with whatever we throw at it, as long as it's fairly familiar. Worse by far are the trans unsaturated fats. These are almost all manufactured by adding hydrogens or partially hydrogenating some unsaturated fat, like soybean oil. So trans fat and hydrogenated fats are the same thing. One refers to the process through which they are created, and the other their chemical structure. These are fats that have double bonds and stack well. In fact, they stack even better than saturated fats, and our biochemical systems aren't designed to break them down, and they interact badly with cholesterol. A 2% increase in daily intake of trans fat corresponds with a 23% increase in the chance of heart disease. Amazingly, they were initially seen as a healthy alternative to saturated fats, and are now in the process of being completely banned in America. Now, even inside these categories, there's a ton of variation, and inside that variation comes more active areas of research, which is less known for sure. Polyunsaturated fats, or fats with more than 1 double bond, might be more or less healthy than monounsaturated fats. No one really agrees because they both have benefits and drawbacks, and it matters where in the chain the double bonds are. You should probably have some of both. And if the double bond is just before the 3rd carbon from the end, we call that an omega-3 fatty acid, and they seem to have a wide range of benefits. They are also one of the 2 essential fatty acids, the other being omega-6. Essential compounds are chemicals that our bodies need to function correctly but can't manufacture on their own, so we literally need to eat those kinds of fats in order to survive. And indeed, we need to eat fat in general to survive. It's good for you in the correct quantities. So those are the basics of fat, you guys. They have tons of energy in them, so they're great when you need calories, but they also make it super easy to eat too many calories. They're absolutely necessary for life. They taste good and are good for you, but unsaturated fats are better, and trans fats might very well kill you. Thank you for watching this episode of SciShow, which was...
All right, so again, that just highlighted some of the things that I am trying to emphasize that I want you to know about these 3 different types of fats. Now, in terms of fat digestion and absorption, here's a slide that is going to tell you where those processes occur. So in our mouth, there's going to be a lipase that's secreted. So lipase is an enzyme that can break down triglycerides. That lipase isn't very effective though, so there's just a little bit of fat digestion that would occur in our mouth. In our stomach, our stomach also makes a lipase, this enzyme that hydrolyzes or digests triglycerides. There's a little bit of digestion that occurs in the stomach. And then as that material moves into our small intestine, there's going to be bile. So bile is this molecule that's made from cholesterol, and it helps emulsify fats. So it's stored in the gallbladder and then gets released into the small intestine as fat enters. And our pancreas is also going to respond by making a bunch of different lipases. So most of the digestion is going to occur in the small intestine because of all these lipases the pancreas is making. And there's going to be bile put into the small intestine, which emulsifies the fat and helps us absorb it. So most of the digestion and absorption is happening in the small intestine. And not very much fat is going to make its way through your small intestine into your large intestine. And if you do have a lot of fat entering your large intestine, typically you're going to have problems, like you're going to have diarrhea. And this can be an issue, say, if you have your gallbladder taken out and you eat a fatty meal, you're not going to be able to absorb that fat because you can't control your bile very well. And so it'll make its way into the large intestine and induce diarrhea. All right, so again, with absorption, it primarily happens in the small intestine. The shorter chain fatty acids are going to be more soluble in water. So a lot of those will get absorbed in our blood and enter the portal vein where they go to the liver. The longer chain fatty acids aren't very water soluble. So typically they're going to be absorbed and enter our lymphatic system, and they'll be delivered to the liver through our lymphatic system. So again, that's just shown here. This would be the lumen of our small intestine. Lipases are going to be breaking down the fats, and bile is going to be emulsifying them, and then they'll be absorbed across the microvilli, and the short chain fatty acids will go into our blood, the portal vein, and be trafficked to our liver, and the liver will do with them what needs to be done. Whereas the longer chain fatty acids are going to enter our lymphatic system and get delivered to the liver eventually. All right, so I've been saying that these fats aren't soluble in water, and our body is primarily made out of water, right? Our blood is primarily water. So we have to have a way to transport these fats around our body. And the way we do this is through structures called lipoproteins. Okay, so a lipoprotein, a cartoon of one is shown here. It's basically a shell that is made out of lipids, right? And so the shell consists of phospholipids. They're shown here. They have this little pink head group and fatty acid tails. They're made out of cholesterol. So that cholesterol shown as the kidney bean looking things that are yellow, and they're made out of proteins that sit in the membrane. So the shell, again, it's phospholipid, cholesterol, and proteins. And what's in the middle here is the cargo, and that'll be some sort of fat. In this case, it's triglycerides are in this lipoprotein. So the big point that I'm wanting you to remember, lipoproteins are these structures that function is to carry fat around through our blood. And the shell is composed out of phospholipids, cholesterol, and protein. So there are different types of lipoproteins that carry different cargo. There are lipoproteins called chylomicrons, and they transport triglycerides. There are low density lipoproteins. There's one called very low density lipoprotein, and there's one called low density lipoprotein. Very low density lipoproteins also carry triglycerides. LDLs and HDLs, so low density lipoprotein and high density lipoprotein, carry cholesterol around our blood. And when you go to the doctor and have your cholesterol measured, they're not directly measuring cholesterol, they're measuring these lipoproteins, LDL and HDL. So you might hear people talk about bad cholesterol and good cholesterol. LDL is typically known as the bad cholesterol. And it's considered bad cholesterol because it's what takes cholesterol to our cells, and it can build up at high amounts and cause problems. HDL, or high density lipoprotein, is known as the good cholesterol. And it's known as the good cholesterol because it's the lipoprotein that will take up excess cholesterol, bring it back to our liver where it can be recycled. All right, so if you're going to go into healthcare, you're going to hear tons about these lipoproteins. So I want you to know what they're doing. And this slide is, or the next couple of slides are just meant to help you understand LDL and HDL. So LDLs are low density lipoproteins. Lipoproteins are what are going to carry fats around. In the case of LDLs, they carry cholesterol. So here you're looking inside a blood vessel, and LDL is in the blood. It's carrying cholesterol inside of it. That shell is made out of phospholipids, cholesterol, and proteins. So there's a protein receptor on its surface, and it'll travel in the blood. And if a cell is low on cholesterol, it will make a receptor called an LDL receptor that protein on LDL can bind to. And it'll bind there, and then the cell can take it up and get the cholesterol that it needs. So this works great. The problem that happens typically is people eat too much cholesterol, or less common, their liver makes more cholesterol. And this results in an excess of LDL in our blood. So we're having more LDL in our blood than is needed by our body, and it'll become oxidized. And that just means it kind of gets old. And our immune cells, these white blood cells, want to try to remove the LDLs. So they'll take them up, and they'll take up these oxidized LDLs. And in taking them up, when there's lots and lots and lots of LDL, it'll kill the white blood cells. And this results in kind of a layer of plaque that forms on our arteries, or a layer of gunk. So here's an artery. When we have excess LDL in our blood, our immune cells try to get rid of it as it becomes oxidized, and they end up dying. And so we get this buildup in our arteries, and it builds over time. And when it gets big enough, it can occlude or block the flow of blood. And so this can lead to things like heart attack. That would be, blocking the flow of blood to the heart. It can lead to stroke. This means blocking the flow of blood to the brain, or all kinds of embolisms. Like you might have heard of pulmonary embolisms. That just means part of this plaque is broken off, and a pulmonary embolism means it's then caught up in the lungs, and it's blocking flow of blood to the lungs. So it's important for you to know about this, because cardiovascular disease is the #1 killer in the US, and it's largely preventable by, say, not eating cholesterol. So again, LDL is taking cholesterol to cells. When we take in more cholesterol than we need, it's going to cause problems and lead to this atherosclerosis, or the buildup of plaque. High density lipoprotein, or HDL, is a good cholesterol, and what it does is it takes the excess cholesterol and takes it back to our liver where it can be recycled. So I have a little video that tries to restate some of the things I just mentioned about HDL and LDL.
If you or someone you know has been diagnosed with high cholesterol, it's important to understand what cholesterol is and why it's important to keep it under control. Cholesterol is a fat-like substance made by your liver, and also comes from foods you intake that is then packaged into particles called lipoproteins. Your body needs cholesterol to make hormones, vitamin D, and a substance that helps you digest food called bile. This video discusses two types of lipoproteins that carry cholesterol: low-density lipoprotein, or LDL cholesterol, also known as bad cholesterol, and high-density lipoprotein, or HDL cholesterol, also known as good cholesterol. LDL travels through your bloodstream, delivering cholesterol to the cells that need it. If your body has too much LDL, it can build up in the walls of your arteries. LDL and other substances in your artery wall form a fatty deposit called plaque. Over time, plaque can narrow the artery and reduce blood flow. LDL carries cholesterol into the plaque. This is why LDL is called the bad cholesterol. A common place this plaque can build up is in your coronary arteries, which are the blood vessels that feed your heart. This plaque buildup causes coronary artery disease and increases your risk of a heart attack. Plaque buildup in other arteries, such as the carotid arteries in your neck, can reduce blood flow to your brain and increase the risk of a stroke. Your liver also makes high-density lipoprotein, or HDL, also known as the good cholesterol. HDL helps remove excess cholesterol from your cells, tissues, and from plaque in your blood vessels. This is why HDL is called the good cholesterol. HDL returns the excess cholesterol to your liver, which removes it from your body. If after viewing this information you have questions about cholesterol or any
All right, so again, you can expect me to ask you some questions about HDL and LDL because our cholesterol levels are intimately tied to cardiovascular disease, and cardiovascular disease is the #1 killer of people in the US. So this develops because we have the buildup of plaque on our artery walls. That's called atherosclerosis. And eventually those arteries get blocked, and that can lead to things like heart attack or stroke. So risk factors include some things you can't change. So, as you get older, if you're male, and certain races have higher incidence of cardiovascular disease. And then some people have genetics where their liver just makes a lot of cholesterol, and that's not something that you can, change. But there are lots of lifestyle risk factors, and most cardiovascular disease is a result of lifestyle. So high blood cholesterol and high triglyceride levels can lead to things like hypertension, which is high blood pressure. A risk factor would include smoking. So if you smoke, that's going to increase your risk of cardiovascular disease. If you're not active, if you don't exercise, you're going to have an increased chance of getting cardiovascular disease. And then if you're obese or have diabetes, these are also huge risk factors for developing cardiovascular disease. And remember, I said every pound of fat has about a mile of capillaries or blood vessels that flow through it. So, if you're 1 pound overweight, that's an extra mile of, distance that your heart has to pump blood. So if you're 100 pounds overweight, that's 100 miles extra that your heart has to pump blood. And your heart's a muscle that, you don't want to wear out because you kind of need it to work. All right, so if we want to prevent cardiovascular disease, what's recommended is to limit our intake of fat. So total fat intake recommendation, or the AMDR, is about 20 to 35% of our total calories. Diets like the Atkins diet or the keto diet go directly against this. And if you follow those diets, you're setting yourself up for cardiovascular disease. The big things are you want to be aware of what type of fat you're eating. So we want to limit the amount of saturated fat, and the saturated fats are mainly found from animal products. And you can find them in some plant things like coconuts or tropical like fruits like that. You don't want to take in trans fat, and ideally you don't want to take in a lot of cholesterol. And again, cholesterol is only found in animal cells. So if you don't eat animals, you're not going to have to worry about eating that cholesterol. What you do want to do is eat a lot of plants, and that's because plants have fiber and they have no cholesterol. That fiber is going to, say, prevent you from absorbing lots of fats and cholesterol. And then you want to do things like keep a ideal body weight and be physically active. So basically things that Americans don't do, and that's why cardiovascular disease is a big issue. So one of the big themes is if you want to have a healthy body, you need to eat plants primarily. So fruits, vegetables, and whole grains. And if you do that and you exercise, you're going to be unlikely to get cardiovascular disease. The very last thing I want to mention is a type of fat called brown fat. So most fat, when we think about it in our bodies, we think about white fat, and fat's white. Like if you go to the butcher counter and you look at a steak, it'll be all marbled, and that's fat. And a fat cell is going to have this big globule of triglycerides, and they look white. There's another type of fat called brown fat, and these cells that have brown fat in them look brown because they have a little organelle in them that's present really abundantly called mitochondria. And mitochondria are like the energy powerhouses of cells. So what brown fat cells do is they burn triglycerides to make energy, and specifically they burn it to make heat. So you may know people that eat and eat and eat tons, but they don't get fat. And that may be in part because they have lots of brown fat on their body, and they're just burning through excess calories to stay warm. So I have a little video that is going to explain what brown fat is.
Would you believe a few simple changes in your diet can drastically reduce your joint pain and arthritis?
And I don't know why that's...
In 2009, doctors in the United States made a surprise discovery. While looking for cancerous cells, they found brown adipose tissue, or BAT, for the first time in adults. It's located in the upper chest and neck. There's not much of it, just a few grams, but it evidently plays a major role in regulating body temperature and in metabolizing ordinary white fat.
It was a minor sensation. When the 3 papers appeared in the leading medical journal, the scientific community sat up and listened. This was the first proof that brown adipose tissue is present in adult humans and also incredibly closely involved in obesity.
The discovery that BAT plays a key role in lipoprotein metabolism is of huge significance. The consensus used to be that brown adipose tissue was only present in newborn babies. They don't have enough muscles to warm themselves through shivering. Instead, BAT on the back, along the upper half of the spine, and toward the shoulders generates warmth.
So I think
its cells do not store energy as white fat cells do, but use it for what's called thermogenesis, creating heat in its own tiny power plants, the mitochondria. And there's more, much more. Jörg Herren of the University Medical Center Hamburg and his team have been researching the function of BAT in mice. 2 mice both got the same amount of food. One got fat. The other one spent nights in a cold chamber and remained thin. It had developed more BAT. Its body appears to have turned up its internal heating and used lots of energy instead of storing it in white fat. Recent research suggests
All right, so that's being super glitchy. I don't want to force you to sit through those pauses, but the point of the brown fat is it is a type of fat cell that will burn through triglycerides to generate heat. And there's a lot of emerging evidence that if you just allow yourself to get cold for even brief periods of time, like 15 minutes, you'll induce the production of brown fat and you'll start burning through more calories. And it's also thought one of the reasons why we're seeing an increase in obesity is because we spend all our time in temperature controlled environments. So we go from building to building, you know, all the buildings are set at 70 degrees or whatever, and we don't get cold anymore. So we're not generating that brown fat that burns through calories to keep us warm. So, you know, if you want to lose weight, one new strategy might be to allow your body to get cold every once in a while. All right, so that's all I have to say then about fat. And I am happy to answer any questions as they arise or come up. And good luck getting stuff done this week.